What you're seeing here is an example of a relatively simple and small protection blueprint, which is sometimes called a guard spec. Applying protections like these to a relatively small compiled application takes a few seconds at most. Here's an example of a more sophisticated guard spec. Sophisticated guard specs for larger apps are typically created by organizations that either find themselves under attack more often, need to defend against more sophisticated adversaries, have larger apps to protect, or a combination of all of the above. Some of the largest and most popular games in the world run on desktop operating systems. The biggest revenue-producing games so far in 2023, for example, are both downloadable desktop apps, and each generated more revenue equal to or greater than the gross domestic product of some countries. Here's what the application security engineer or the application owner sees when they apply that protection blueprint to the compiled code of a large application. The incentive to cheat in games with marketplaces is powerful. Someone who can figure out how to reverse engineer a game such that they can buy the latest wand or the latest grenade launcher can not only create a god mode for him or herself, they can also potentially sell their exploits on the black or gray market for considerable sums. And games that don't feature marketplaces, meanwhile, still rely on security to ensure fair gameplay and thus maintain their popularity and success. Combined, the large application footprints and the imperative to protect large parts of those large files create the need for some of the most complex and thorough protection blueprints or guard specs that we see. Adding these protections to large files can take a long time, and the longer it takes to add protections, the longer the famous infinity loop or feedback loop will take in a team that's following a DevSecOps methodology. Typically, these companies will update the protection blueprint based on reports of a trending attack vector, or to protect some incremental improvement in the game. When they're adding these new protections, they'll of course want to test the new protection before they release it into production. A large protection blueprint plus a large application can thus lead to long wait times for the implementation of protection step. We've recently simplified that step so that implementation of even the most sophisticated protections now takes less time, something closer to this. Some customers who have already tested this new Corbett feature have reported that the implementation of protection times is more than 20 times faster. This means that the infinity loop is able to operate with greater efficiency, more iterations and revisions of software are created more quickly, and end consumers experience a higher quality, more secure application.